Welcome back guys to engineering tutor. So again today we are going to discuss the problem number 6 of our book, which is the introductory circuit analysis by Robert L. Boylestad. So in this question we are given the voltage and the current which has been flowing through the load here, but what we have to find out, we have to find out the impedance or the total load which has been connected with this voltage source. Similarly, in part B of this question, the same statement of the question has been used, that we have to find the impedance or the internal impedance which is inside this black box. Similarly, here in part C, the black box is again connected and again we have to find out the impedance. Okay, so let us start doing it from part A, and here we have to find the impedance and then we have to represent it as a simple series circuit that will satisfy the indicated conditions. Okay, so what are basically the conditions? Conditions are mentioned in the form of the current and voltage. So let me start it with the first question, and in this question we are given the value of current, the value of voltage, and we know that by Ohm's law the value of impedance is Z equal to V by I. Okay, or here V is E, so E divided by I, the value of E is given, that is 120 volts with 0 degree. So 120 volts with 0 degrees, and the current here is also given, and that is 60 amperes with 70 degrees. Okay, with this 70 degrees. So what we have to do here, we can see that both of these quantities are in polar form, and we have seen in our video which was related to the phasors that polar form is one of the most feasible form for the division and the multiplication of two complex quantities. So here it is already in this form. So doing it right away, what I will get, 120 divided by 60, and angles here will be 0 degrees minus 70 here. Okay, sorry. So here I will have 2 because this will cancel out with this one, and here I will get minus 70 degrees. Okay, so here we have this one, and this is in ohms with the minus 70 degrees. But from here we cannot get to know that how much resistive will I have here and how much inductive or capacitive, which is basically the reactive element which we will have. Okay, so in order to do it, here we can see that here we have this voltage, this is E, and the current which is flowing through it is this I, and here the inside of it, this is that black box. Let me represent it with this. Okay, and here this one, and inside of it I will have two components. One will be connected here, the second will be in series with it. Okay, so it will be like this one. So here this can be the real component, this can be the imaginary component, and from it we can see that which type of component is it. So therefore we have to convert this polar form into the rectangular form. Okay, so what we have to do, let me go to the calculator. We can also do it manually, but in order to simplify the procedure here, I am going to use this calculator. So here the amplitude is 2. Similarly, the angle associated with it is basically minus 70 degrees. So minus 70 degrees. Okay, so that is basically the quantity, and here we can very easily see that it has already been converted into it. So writing it here, it will be 0.68. okay, and the imaginary quantity is 1.88. okay, with it I is written here, I am going to write here J. So that is the impedance here, and here we can see that the first element here is the real quantity, so therefore this is the resistance, and as with the reactive element or the imaginary quantity here, negative is written, so therefore this one here is basically the xc. Okay, writing them here, I will get here r and here jx of c, and the values of these quantities are already available here, and these are these values. Okay, xc is 1.88, which is here, and the value of r is 0.68. Okay, so that is the solution of part A. Similarly, in order to proceed here, let me start part B of our question. Again, the same scenario, the same formula is applied. Z is equal to V by I. So V is given, that is 80 volts with the angle of 320 degrees, and I is 20 milliamps. So 20 into 10 raised to the power minus 3. Okay, and the angle associated with it is 40 degrees. So again, simplifying them, writing them, what I will get, 80 divided by 20 into 10 raised to the power minus 3, here 320 minus 40 degrees. Okay, let me move down again. Here calculating it, I will get here this 4 into 10 raised to the power 3, and the angle here will be 280 degrees. Okay, so this is now an ohm, where this 4 into 10 raised to the power 3 is basically the thousands. So again, we have to find out the impedance inside of it. Okay, so that is basically positive, negative E, while the current is flowing through it, and inside of it we have two blocks. This one is the resistive block, and also this block. Okay, so these two are in series. Here this will be of this will be the real quantity, and this will be of imaginary quantity. So in order to do it, we have to convert this one into the rectangular form. So what we have to do, again, let me go here, and here writing 4000, and the angle associated with it is this, and 280. Okay, now pressing equal, it will give me 694.6, because rounding it off to the one decimal point, so 694.6, 694.6, and the other quantity with it is, this is again negative, so minus 3939.2 minus J 3939.2. Okay, so now this is the impedance of part B, so let me call it Z of P. So here the values, now this one is the value which is for the resistance, and while this one is for the reactance. And which type of reactance is this? This is a capacitive reactance, because of the availability of this negative sign with it, so that is X of C. Okay, so now writing their values, I will get here this R, and here it will be Jx of C with the negative. So that is for part B, where we again have constructed this circuit, where the first element here is the resistor, while the second element is here this circuit. Okay, so plus minus V, this is current, and the value of this is 694.6 ohm, okay, and the value of it is minus j 39, sorry, this is 39.2 ohm. Okay, so this is the series circuit which we intended to find out. In part 3 of this question, again let me come towards it, and again finding the value of the impedance which is inside of this black box. Okay, what we have to do, again we have to use the same formula, and for that E is 8 kilovolts with the 0 degrees phase, while the current here is of 0.2 amps with the minus 60 degree amps. So here let me start part C. So for part C, Z of C is again V by I. The value of V is how much? The value of V here is 8 kilovolts with 0 degrees. So 8 into 10 raised to power 3 with the 0 degrees angle and divided by the current. The value of current here is how much? 0.2 amps with the minus 60 degrees angle. 0.2 amps with the phase of minus 60 degrees. So now doing it, what I will get again, 8 into 10 raised to power 3 divided by 0.2, okay, and the angles here will be 0 plus 60 degrees because now it has moved upward, so the sign with it has been changed. So 8 divided by 2.2 is how much? 8 divided by 0.2 is 40. Okay, so now 40 into 10 raised to power 3 and the angle with it is 60 degrees, so that is in ohm. Now again the same procedure, the same thing, because what I have to do, I have to find the value of the resistance and also the value of the reactive element which is connected in series with it, while the voltage here is 8 kilovolts with the 0 degree angle, while the current which is flowing through it is I is 0.2 amps with the minus 60 degrees. Okay, so here we have to find out the other values which are this resistance and this reactive element. So now in order to do it, what we have to do, we have to convert this one into the rectangular quantity, and from it we will get this Z of C. Okay, so how to do it? I have been doing it by this calculator. So again writing 40,000 is 40, 1, 2, 3. Okay, and the angle with it is this, and the angle is 60 degrees. So now writing this equal, and here I will get 20,000 or 20k. Okay, and the other quantity with it is plus j, and with that plus j I have 34.641. okay, so that is very huge quantity, 34.6 kilo. Okay, so that is basically the value of the resistor. Okay, while this is the value of the reactance, and here we can see that the sign with this imaginary term is positive, therefore this is basically the inductive reactance. Okay, so writing it X of L, so therefore here this will be X of L, this will be R, and the values these will have will be, this is 20k ohm, while this X of L is how much? This is 34.6K. okay. So that is the solution of our question, in which we have seen that how to find out the value of the unknown impedance if the voltage which has been developed across it and the current flowing through it has been known. okay. So I hope all these steps, all the things which I have covered in this video are clear now. So that's it for today, and I will see you with some more videos in our upcoming lectures. Thank you so much.